Okay, and good morning and welcome to Chapter 3, Notes 3.1, Radian Measure. Your objective in this one is you will convert between degrees and radian angle measures, and you will find exact values of trig functions given a radian angle measure. So everything that we've done before, we're just changing things to radians. So three different types of angle measure: the revolution, which was the first thing we played with. You know, how many times does it revolve around the circle? The degree, and then the radian. The most important unit of angle measure in mathematics is the radian. You would go into calculus, it's almost 100% only radian measure. So this is stuff we've got to make sure that you know. Radian measure also allows us to treat the trig functions as functions with real number domains. I don't want you guys going, what, 360 is not real? Well, yeah, but when it comes to mathematics, it's just a degree. So radian measure helps us to put trig functions on a coordinate plane, which is chapter 4 we get to graph. Yay! Okay, so one complete circle has 2 pi radians, approximately 6.2 radians. A radian is almost 1/6 of a circle, 1 radian. A radian is a little more than 57 degrees. So if you go, oh, it's about 60, you'd be right. It's right about there. A single radian is when the measure of an angle that creates an arc length equal to the length of the circus, the radius of a circle. And here's a picture of 1 degree, very little, 1 radian. You can see it is quite large. And this is where I also get to remind you that you've actually played with radians before, because way back in geometry, circumference of a circle, 2 pi r, 1 full rotation times the radius, because the radius is going to determine how big that thing is. Same thing with area. Area equals pi r squared. So there it is. You've played with radians before, you just didn't know it. Okay, so to give you a little bit of example between a degree and radian, if this one's degrees, then this would be 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then our full rotation of 360 degrees. Now radian starts out at 0, and a full rotation comes from that circumference is 2 pi. So if I do half of the circumference, I'm at pi. And then the halfway point between 0 and pi, pi over 2. And the halfway point between pi and 2 pi would be 3 pi over 2. This gives you a little example of 0 to 90 degrees, how this one is just 0 to pi over 2. Much smaller values that we can play with. Okay, the main thing we need to do is be able to convert between degrees and radian measures. This will be something that you might want to put on your card at the back of the one sheet. 1 radian equals 180 over pi, or 1 degree equals pi over 180 radians. If no unit, this is an important one, if no unit of angle measure is specified, then the angle is understood to be measured in radians. You don't put that degree symbol on there, so you go, oh, this is 45 degrees, and you write it like that. It's read as 45 radians. So keep that in mind. Degrees does not equal 45 radians. So you have to make sure you're paying attention to these things now. So converting between the two, multiply a degree by pi over 180 radians and simplify to convert to the radians. These will be left in terms of pi. Yeah. And so you'll always be a whole number or fraction. No decimals. and multiply a radian by 180 over pi and simplify to convert to degrees. This one, most likely no fractions, um, will be a whole number or decimal. Now, from things I've seen in the past, a lot of you guys are going, okay, got it, got it, got it. But when it comes to doing it on your own, you're forgetting some of the little rules. So be really cautious. If you're multiplying by the fraction, you'll get a whole number or fraction back. If you're dividing, well, both of them are multiplying by the fraction, but if you're starting with the degree, you can get a whole number or fraction. And if you're multiplying by the radian, you'll get a whole number or decimal. Basically, pi is still in the mix. Pi is still in the mix, but we'll have those also that are different. So maybe I should say if you're multiplying by pi, whole number or fraction. If you're dividing by pi, there it is, whole number or decimal. So the first three problems: convert each degree measure to radians and each radian measure to degrees. Well, this is degrees, so we're going to do 480 time over 1 times pi over 180. Now remember, this is to be left in terms of pi, so don't throw this in the calculator. So you can rewrite it as 480 over 180 times pi. When you put the 480 over 180 into your calculator, simply go through and put 480 over 180. So I'll type it in there. 480 divided by 180, and then hit math, your math button, and then enter, enter. This will give you a fraction. So this one's going to give you 8 over 3, and then you multiply pi to the side. Now here's the deal with this 8 over 3 pi. I don't care how you write it, don't care how you say it, as long as you do not put pi in the denominator. I always put pi in the numerator, so we would word it as 8 pi over 3. Okay, so next one, 15 pi over 4. This one is in radians. Notice no degree symbol. So to go to radians back to degrees, 15 pi over 4 times 180 over pi. Most of these problems, when you're going from radians to degrees, you'll be able to cancel out the pi's. So you have 15 times 180 divided by 4. So you throw that into the calculator and you get 675 degrees. Don't forget the degree symbol. Chapter 1 and Chapter 2, I could be a little bit lenient on them because we were only doing degrees. But after this, we won't be able to. Okay, 174 degrees, 50 minutes. This one here, this is what I'm going to tell you guys, be really, really cautious. Use that degree and minute symbol in the calculator. So you're going to put it into the calculator, 174 degrees, 50 minutes, over 180 degrees. You type that into the calculator, and you get a number of 1,049 pi over 1,080. Yeah, sometimes the fractions look extreme, but there you go. And this is one of the things that we can look at. I already pointed out 180 degrees is just pi. And so you can see that this is definitely close to 180, which makes sense that this fraction is quite close to 1. Okay. So now they're going in, they're going to convert radian measure to degrees. Notice there's no pi on these. Radians can be written with or without the pi. But remember that when you convert radians to degrees, you'll get a whole number or a decimal. Now this one does say round to the nearest minute, so we'll have to change it. So this is 5 over 1 times 180 over pi. So in the calculator, you're going to do 5 times 180 divided by pi. And then you're going to type in the button second, apps, and then the degrees, minute, second button, which is the fourth one down, to get your degrees, minutes, seconds. I don't need to know what your decimal value is. It helps to know what your decimal value is because some people are still going through and converting, but I want you guys to start using that calculator. So on this one, when I throw this in, I get 286 degrees, 28 minutes, and 44 seconds. And this says round to the nearest minute. So 44 is more than half. Remember, 30 seconds equals a half a minute. This is more than 30, so we're going to round this baby up. So this is 286 degrees, 29 minutes. Okay, once you guys go ahead and give yourself a shot at this one, try this one, see if you get the same answer. Don't forget to use the second app, DMS, to get your answer right away. Okay, so you're going to throw in the calculator negative 3.57189 times 180 over pi. So negative 3.47189 times 180 divided by pi. And then the second apps DMS. And you should have gotten negative 198 degrees, 55 minutes, and 28 seconds. And this is when I can point out to you, notice 28 is not more than half, so we're going to just stick with the 55 minutes. Negative 198 degrees, 55 minutes. How'd you do on that one? Okay, now we'll give you that quick little introduction to the unit circle. And so this is going to be a nice little practice for you. Just use a calculator, don't have to show work, and identify, I gave you either degree or radian measure, and just go through and do the math. Pause this because I'm just going to race through and just put the values in. I'll put any missing degrees in first, and then I'll go back and do the radians. Good luck. This might take you a while. Okay, let's see how you guys did. So 0, 30, 45 degrees, 60, 90. I'll let you know that these are, the pattern here is 30 degrees, 15 degrees, 15 degrees, 30 degrees. So all of the bigger ones are 30, the little ones are 15. So 30, 15, 15, 30. It goes around, it continues. So 90 plus 30 is going to give me 120, plus 15, plus another 15, plus another 30, plus 30, plus 15, plus another 15 will give me 240, plus 30 is 300, 315, 330, and full rotation 360. Now I want, as you do the radians, I want you to notice how the denominators are changing and the numerators are changing. Okay, so 30 degrees, I'm not going to do the math for you because it's where you get to do the practice. This is going to be pi over 6, but I will point things out to you. Pi over 6. This one is as well 30 degrees off of the x-axis, so it also will be pi over 6. It's just not pi over 6, it's 5 pi over 6. You get to calculate that one. Notice this is pi over 4. This one also has a pi over 4. This one has 2 pi over 3, so this one also has pi over 3. And I've already told you about here 0. Full rotation is 2 pi. Half rotation is pi. So a quarter rotation would be pi over 2. And then we come to the bottom side. Notice that was pi over 2 up here, that this is 3 pi over 2. Okay, so again, right off the x-axis is a pi over 6, but this one is 11 pi over 6, and this one over here is also a pi over 6. This one is 7 pi over 6. The first little 15 one is going to be a pi over 4. This one's going to be 5 pi over 4. This one also is a pi over 4, but this one here is going to be 7 pi over 4. There are patterns, and I will be asking that you guys find those patterns so that you don't have to do the calculations every little itty bitty time. But when it comes to reference angles, this is really, really nice, because let's use 45. All of your 45-degree angles, the one that's right smack in the middle here, pi over 4, pi over 4, pi over 4, pi over 4. So if I asked you for cosine of 7 pi over 4, you're going, oh, pi over 4. And you're going to go to your table going, pi over 4 is this. And then you just have to identify if it's positive or negative. Much easier than degrees to figure out your reference angle. Okay, now I'm sure that one took you a while. Okay, now it says find the exact value of each expression without using a calculator. Now this is where I get to remind you, and I don't have it on my thing, that you have your sine, cosine, tangent, cosecant, secant, cotangent, and then you have your 0, 30, 60, 9, oops, forgot the 45, 45, 90. You might want to put up there now that this is 0 or 2 pi. This is pi over 6, pi over 4, your 60 is pi over 3, and pi over 2. Because now if you have a pi over 6, you're just going to go to that 30-degree angle, pi over 4, and so on. So this one here, pi over 6, so you know it's a 30-degree angle. It is the 30-degree angle. So you look at your chart. So we'll make reference, pi over 6 is equal to 30 degrees, so you get that little reminder. And cosine at 30 degrees is radical 3 over 2. You're going straight to that table and you're looking at it. Nothing more. Okay, so this one here, 2 pi over 3, and you come over here going, oh, it's a 60-degree angle. Okay, cool. So you can write down your reference angle is pi over 3. And you look at your paperwork and you go, oh, so cotangent at pi over 3 is radical 3 over 3. The question is it positive or negative? So use your little all students take calculus. All students take calculus. And it's okay if you flip back to this last page and go, oh, 2 pi over 3, here we are, we're in quadrant 2. So you're here. And sine is not positive. I'm sorry, sine is positive, so tangent must be negative. Done. Now, this is what I get to throw out there. Anytime they say exact value, that means translate to no decimals. You will get marked wrong. you give me decimals, because I'm not going to go in there and figure out what the decimal value is. Okay, one more here. Secant at pi. Now, hopefully you remember by now that pi is equal to 180. So you can go to 0 or you can go to 180. But secant at pi is equal to -1. If you used secant at 0, you would have gotten 1, but this is over between quadrants 2 and 3, which is values of x are negative. Okay, find exact values again. We're still doing these, no calculators. So 13 pi over 3. So you know it's a pi over 3. So reference angle, pi over 3. And so you go to your table and you go, okay, cosecant, oh, let's write this to the side. Because it's not the answer, so let's just write it to the side. Cosecant of pi over 3 is equal to 2 radical 3 over 3. The question is, what quadrant are we in? So this is where you have to do some math. So remember, 2 pi equals 1 rotation. So I have negative 13 pi over 3, and since I have a denominator of 3, I need this guy to have a denominator of 3, so I will simply multiply by 3 over 3. So I get 6 pi. So I'm going to add 6 pi over 3, and I get negative 7 pi over 3. So I add 6 pi again, and I get negative pi over 3. So I'll add 6 pi again, and I get this time 5 pi over 3. Now at this point you may be going, I don't know what quadrant I'm in, and you can use the calculator on this one. I might as well throw that out there to you guys. You can use the calculator on this one. Just leave out the pi. Do 13 over 3, negative 13 over 3 plus 6 over 3 until you get to a positive number. So let's go back to our unit circle and find 5 pi over 3. There it is, 5 pi over 3 is in quadrant 4. So we're in quadrant 4. And in quadrant 4, if you need to, you're going to do it. All students take calculus. This is for cosine and secant. Cosecant, so it's going to be negative as well. So your answer is negative 2 radical 3 over 3. I know you might be thinking, well, wow, this is a lot of work, but keep in mind the practice. You could have done this all in a calculator. Negative 13 plus 6 gives you negative 7. Negative 7 plus 6 gives you negative 3, 1/3. And add the 6 again, and you get 5/3. You just have to know where you are. Some of you will start playing back and forth with degrees and radians until you're feeling more comfortable, which is okay. Okay, next one, cosine of 3 pi over 2. That one, remember this is pi over 2, and this is 3 pi over 2. So no quadrants. We just know that down here the y's are negative. But your x value is 0. So if you went to cosine of 90, you would have found 0, and you would have been dead. Nothing more to that one. Okay, but what about secant? So this is where I get to throw in there secant is the reciprocal of cosine. And we already know cosine at 3 pi over 2 is 0, so secant must be undefined. Okay, and there you guys have it. Your first section and chapter 3. Good luck on the homework.